and the gentle stillness of evening as shadows lengthen and the world begins its slow transition toward night, a profound question whispers through the silence. What is time, really? It's a question that has haunted humanity since we first became aware of ourselves, since we first noticed the sun's arc across the sky, the changing of seasons, the rhythm of our own heartbeats, marking the moments of our existence. Tonight, as you settle into the peaceful embrace of rest, let us embark on a journey into one of the deepest mysteries of reality itself. Time feels so immediate, so undeniably real. You can sense it flowing around you like an invisible river, carrying you from the experiences of today toward the unknown possibilities of tomorrow. Every breath you take exists in time. Every thought that crosses your mind unfolds within time's embrace. Every memory you cherish is a fragment rescued from time's ceaseless flow. Yet for all its apparent reality, time remains one of the most elusive concepts in all of human understanding. Consider this moment, right now, as you listen to these words. Where exactly is now? By the time your brain processes the sounds forming these sentences, that moment has already slipped away into what we call the past. The very act of consciousness seems to live perpetually on the razor's edge between what was and what will be, never quite able to grasp the present moment before it dissolves into memory. This fleeting nature of now points to something profound and mysterious about time itself. Our everyday experience suggests that time moves in one direction only, from past through present toward future, like a river flowing toward a distant sea. We remember yesterday, but not tomorrow. We can influence what comes next, but cannot change what has already happened. This directional quality of time, what physicists call time's arrow, feels so fundamental to our existence that we rarely question it. Yet, science has revealed that this arrow may be more fragile and mysterious than we ever imagined. Different cultures throughout history have conceived of time in remarkably different ways. Some see time as a circle endlessly returning to where it began, like the seasons cycling through their eternal dance of renewal and decay. Others envision time as a spiral, combining the circular return of familiar patterns with the linear progression towards something new. Still others experience time as a series of distinct moments, like beads on a string, each complete in itself, yet connected to those that came before and after. Even within your own life, time behaves strangely. Minutes crawl by when you're waiting for important news, yet hours vanish like morning mist when you're absorbed in something you love. Time stretches during moments of crisis, contracts during periods of joy, and seems to accelerate as we age. A child's summer vacation feels eternal, while an adult's year passes in what seems like a few brief months. These variations in our subjective experience of time hint at something deeper, that time as we perceive it may be as much a creation of consciousness as a feature of the external world. The ancient Greeks had two different words for time, recognizing even then that our experience of temporality is not simple or uniform. Chronos represented mechanical, measurable time, the steady tick of the clock, the regular rotation of the Earth, the predictable orbits of planets. But Kairos described a different kind of time altogether, the right time, the meaningful moment, the quality of time that transforms ordinary duration into something significant. Think of the difference between the chronological time you spend with a loved one and the kairos of truly connecting with them. How those deeper moments seem to exist outside of ordinary temporal flow. Modern physics has revealed that time is even stranger than our ancestors imagined. Einstein's theories showed us that time is not universal and absolute, but relative and flexible. Time can slow down or speed up, depending on how fast you're moving, or how strong the gravitational field around you happens to be. This isn't just theoretical speculation. It's a measured reality that affects everything from GPS satellites to particles accelerated in laboratories. The cosmic speed limit we explored before doesn't just govern space, it reveals the intimate connection between space and time, showing us that we live not in space and time, but in space-time, a unified fabric where motion through space affects the flow of time itself. But perhaps the most unsettling discovery about time comes from quantum mechanics, where the familiar flow of past to future begins to break down. In the quantum realm, particles can exist in multiple states simultaneously, as if experiencing several different timelines at once. The very act of measurement seems to collapse these multiple possibilities into a single timeline, raising profound questions about whether time as we experience it emerges from something deeper and more fundamental. Some physicists now suggest that time itself might be an illusion, a useful fiction created by consciousness to make sense of a timeless reality. According to this view, all moments, past, present, and future, exist simultaneously in what's called the block universe. From this perspective, your childhood, this very moment, and your eventual death all exist equally in the fundamental structure of reality. The flow of time, the sense of moving from past to future, emerges from the particular way consciousness samples this timeless reality. Yet even if time is an illusion, it's a remarkably persistent and powerful one. We age, we remember, we anticipate. Causes precede effects. The universe itself seems to have a history, from the Big Bang through the formation of stars and galaxies to the eventual heat death predicted by thermodynamics. Even if the block universe theory is correct, something creates the appearance of temporal flow. Something gives rise to the arrow of time that makes narrative and meaning possible. Perhaps the question, what is time, is like asking, what is consciousness? A mystery so fundamental to our existence that we cannot step outside it to examine it objectively. We are beings embedded in time, creatures whose very thought processes unfold temporally. Every attempt to understand time must use temporal concepts, before and after, cause and effect, memory and anticipation. We are, in a sense, time trying to understand itself. As you drift towards sleep tonight, let your mind rest with these mysteries rather than trying to solve them. Feel the gentle rhythm of your breathing, marking time in the ancient way of all living things. Notice how the boundary between waking and sleeping dissolves the sharp edges of temporal experience, allowing you to float in a timeless space between conscious thought and peaceful rest. In this liminal state, perhaps you can sense something of what time truly is. Not a prison that constrains us, but the very medium within which consciousness flowers, experience unfolds, and the universe tells its magnificent story. The physics of time, Einstein's revolutionary dance with reality. In the quiet hours before dawn, when the world holds its breath between night and day. Imagine a young patent clerk in Switzerland, gazing out his window at the street lamps below. The year is 1905, and Albert Einstein is about to shatter humanity's most basic assumptions about the nature of time itself. With nothing more than thought experiments and mathematical elegance, he will reveal that time is not the steady, universal metronome we believed it to be, but something far more mysterious and beautiful. Einstein's journey into the heart of time began with a simple question that had puzzled him since childhood. What would it be like to ride alongside a beam of light? This innocent curiosity led him to one of the most profound realizations in human history. He discovered that the speed of light is not just fast, it represents something fundamental about the structure of reality itself. No matter how you move, no matter what your perspective, light always travels at exactly the same speed relative to you. This seemingly simple fact would reshape our understanding of everything. Think about what this means for a moment. If you're standing still and shine a flashlight forward, the light travels at 299,792,458 meters per second. If you run forward as fast as you can while shining that same flashlight, the light still travels at exactly the same speed relative to you. Not faster, not slower. This constancy of light speed seemed impossible according to our everyday understanding of motion. Yet it was confirmed by every experiment scientists could devise. Einstein realized that if the speed of light must remain constant for all observers, then something else must be flexible, something we had always assumed was fixed and universal. That something was time itself. In Einstein's elegant theory of special relativity, time becomes elastic, stretching and compressing, depending on how fast you're moving relative to other objects. This isn't just theoretical. It's a measured reality that affects our daily lives in ways both subtle and profound. Imagine two identical twins, born on the same day, sharing the same birthday cake, and growing up together. Now picture one twin remaining on Earth, while the other embarks on a journey to a distant star at nearly the speed of light. During this cosmic voyage, something remarkable happens. Time itself slows down for the traveling twin, relative to the one who stayed home. Not in their subjective experience, each twin feels time passing normally in their own reference frame, but relative to each other. When the space-traveling twin returns to Earth after what feels to them like a few years of travel, they might find that decades have passed on Earth. Their twin has aged normally according to Earth's time frame, while they have aged only according to their slowed-down time. This isn't science fiction. It's a consequence of the fundamental structure of space-time itself. Time dilation, as physicists call it, has been measured countless times in laboratories and affects everything from GPS satellites to particles in cosmic ray showers. But Einstein's insights went even deeper. He realized that space and time are not separate entities, but aspects of a single unified fabric he called space-time. Imagine space-time as a vast, flexible membrane stretched across the cosmos. Massive objects like stars and planets create depressions in this membrane, like heavy balls resting on a stretched rubber sheet. These curves and valleys in space-time guide the motion of everything from planets to light rays, creating what we experience as gravity. This curved space-time reveals another startling truth about time. It flows differently in different gravitational fields. Time passes more slowly in stronger gravitational fields and more quickly in weaker ones. This means that time literally runs faster on the upper floors of tall buildings than in their basements, though the difference is incredibly tiny. Clocks in GPS satellites orbiting high above Earth's surface, where gravity is slightly weaker, run faster than identical clocks on the ground by about 38 microseconds per day. This might seem like a trivial difference, but without accounting for this gravitational time dilation, GPS systems would become inaccurate by miles within hours. Every time you use navigation on your phone, you're relying on Einstein's insights about the malleable nature of time applied to satellites orbiting overhead in their own slightly different time stream. Einstein's general theory of relativity revealed even more exotic possibilities. Near extremely massive objects like black holes, time can slow to a crawl compared to distant observers. An astronaut falling toward a black hole would experience time passing normally from their own perspective. But to someone watching from far away, the astronaut would appear to slow down dramatically as they approached the event horizon, their image frozen at the boundary, like a cosmic photograph. These discoveries fundamentally changed our understanding of what time actually is. Time is not a river flowing uniformly throughout the universe, but more like a landscape with hills and valleys, streams and eddies, each region flowing at its own pace depending on the gravitational terrain and relative motion. Every massive object sculpts this temporal landscape, creating a unique pattern of time flow in its vicinity.
Perhaps most remarkably, Einstein showed us that simultaneity itself is relative. Events that appear to happen at the same time to one observer may occur at different times for another observer, moving relative to the first. There is no universal now that extends across the cosmos. The present moment is not a cosmic slice through time, but a local, personal experience that varies from observer to observer. This relativity of simultaneity means that the universe doesn't have a single universal timeline, but rather countless personal timelines, each valid from its own perspective. Your now is different from the now of someone moving relative to you, even by tiny amounts. The faster the relative motion, the greater the difference in what counts as simultaneous events. These insights from relativity theory began to dissolve the sharp boundaries between past, present, and future that had seemed so obvious in everyday experience. If simultaneity is relative, and if time can flow at different rates in different places, then perhaps our intuitive sense of time as a flowing river is more of a psychological construct than a fundamental feature of reality. Modern physics has pushed these ideas even further. Some interpretations of Einstein's equations suggest that all events, past, present and future, exist equally in what physicists call the block universe, or eternal now.
From this perspective, time doesn't flow at all. Instead, consciousness moves through a static, four-dimensional structure containing all of history and all possible futures. Yet for all these revelations about time's malleable nature, we still experience it as flowing from past to future in our daily lives. The psychological arrow of time remains strong, even as physics reveals the deeper flexibility of temporal reality. This suggests that our experience of time may be more about consciousness and information processing than about the fundamental structure of space-time itself. As you rest tonight, let your mind drift with these ideas, like clouds moving across an evening sky. Feel how Einstein's insights invite you to see yourself not as trapped in time's flow, but as part of space-time's grand geometry. You are not separate from time. You are woven into its very fabric, a conscious pattern in the vast tapestry of space-time that connects every star, every planet, every moment that has ever been or ever will be. Entropy and the arrow of time, the universe's gentle drift toward complexity. Picture a perfect sandcastle on a quiet beach at dawn, its towers and walls sharp against the soft morning light. As the day unfolds, gentle waves lap at its foundation, grains of sand shift in the breeze, and slowly, inevitably, the castle returns to the formless dune from which it came. This simple scene contains within it one of the most profound truths about time itself. The reason why time seems to flow in only one direction, from ordered past toward a more disordered future. This directional quality of time puzzled scientists for centuries. Einstein's relativity had shown that time could stretch and bend, that simultaneity was relative, and that past and future might all exist equally in a timeless block universe. Yet despite these revelations, something still seemed to give time its arrow, its undeniable sense of flowing from what was toward what will be. The answer, it turns out, lies not in the grand geometry of space-time, but in the gentle statistical tendencies of countless tiny particles dancing their microscopic dance. The key insight comes from a branch of physics called thermodynamics, which studies how energy flows and transforms. The second law of thermodynamics tells us that in any isolated system, entropy, a measure of disorder or randomness, tends to increase over time. This isn't a rigid rule that applies to every individual particle or moment, but rather a statistical tendency, so overwhelmingly likely that it becomes practically certain for systems containing vast numbers of particles. Imagine opening a bottle of perfume in a quiet room. The concentrated fragrance molecules, initially confined to the small space within the bottle, begin to spread throughout the room. They diffuse slowly outward, moving from a state of high organization, all clustered together, toward a state of low organization, evenly distributed throughout the available space. You would never expect to see the reverse happen spontaneously, with perfume molecules throughout the room suddenly gathering themselves back into the bottle. This spreading, this tendency toward greater disorder, happens not because of any mysterious force pushing the molecules apart, but because there are simply many more ways for the molecules to be spread out than for them to be concentrated in one small space. Given the random thermal motion of the molecules, the disordered state is overwhelmingly more probable than the ordered one. The universe, in a sense, is constantly exploring all the ways things can be arranged, and finding that disorder vastly outnumbers order. This principle extends far beyond perfume bottles to encompass the entire cosmos. The early universe, in the moments following the Big Bang, existed in a state of extraordinary order. All the matter and energy that would eventually become stars, galaxies, and planets was compressed into an incredibly small, uniform, and organized state. As the universe expanded and cooled, this initial order began to spread out, creating the diversity and complexity we see around us today. But here's where the story becomes beautifully paradoxical. While the overall entropy of the universe increases, this very increase allows for the creation of local pockets of greater organization and complexity. The energy flowing from hot regions to cold regions, from order to disorder, can be harnessed along the way to build structures, power processes, and create the organized complexity we call life. Think of a river flowing down a mountain. The water's journey from high altitude to sea level represents an increase in gravitational entropy, water finding its lowest possible energy state. Yet along the way, this same flowing water can turn water wheels, generate electricity, carve beautiful canyons, and nourish ecosystems of stunning complexity. The universe's drift toward disorder becomes the very engine that powers the creation of temporary islands of order. This is how stars are born in the apparent chaos of collapsing gas clouds, how planets form from the random debris of stellar nurseries, and how life emerges from the chemical soup of early Earth. Each of these represents a local decrease in entropy, a temporary victory of order over chaos, powered by the larger flow of energy from organized to disorganized states.
Your own body is a magnificent example of this principle in action. Every moment, you are borrowing order from your environment, taking in organized energy in the form of food and oxygen, using it to maintain the incredibly complex organization of your cells, tissues, and organs, then releasing waste heat and disordered products back into the world. You are not separate from the entropy increase of the universe. You are a temporary eddy in its flow, a brief but beautiful pattern that emerges from and contributes to the cosmic drift toward equilibrium. This thermodynamic understanding of time's arrow helps explain why we remember the past but not the future. Memories are physical traces left by past events, patterns of neural connections, modifications in brain structure that record information from earlier moments. These traces can only exist because the past was more ordered than the present. The universe started in a low entropy state and has been increasing in entropy ever since, leaving behind it a trail of fossil traces that we experience as memories. The future, by contrast, remains uncertain precisely because it represents the not yet explored space of possible entropy increases. There are countless ways the universe can continue to evolve toward greater disorder, and we cannot predict which path it will take. This is why the future feels open and the past feels fixed, not because of any fundamental difference in the nature of time, but because of the statistical arrow created by entropy increase. Yet this arrow of time is more subtle than it first appears. In the quantum realm, microscopic processes can and do run backward, with particles seeming to violate the second law of thermodynamics for brief moments. It's only when large numbers of particles are involved that the statistical weight of entropy increase becomes overwhelming. Time's arrow emerges from statistics, not from fundamental physics. Some physicists speculate about what might happen in the far future, when the universe has expanded and cooled to the point where entropy reaches its maximum possible value. In this state, called thermal equilibrium, there would be no temperature differences, no energy gradients, no flows of any kind. Would time itself cease to have meaning in such a universe? Would the arrow of time disappear in a cosmos where nothing could change because everything had already reached its most probable state? But that far future, if it comes to pass, lies countless billions of years ahead. For now, we live in a universe rich with entropy gradients, a cosmos still young enough that order and disorder dance together
in intricate patterns. The same thermodynamic processes that drive time's arrow also make possible the warmth of sunlight on your skin, the growth of forests, the beating of your heart, and the formation of thoughts in your mind. As you settle into sleep tonight, feel yourself as part of this vast, gentle current of entropy increase, your body cooling as it rests, your thoughts becoming less organized as consciousness fades, your breathing slowing into the peaceful rhythm of dreams. All of this is the universe's entropy gently increasing, time's arrow carrying you from the ordered awareness of day toward the disordered rest of night. In this surrender to disorder, you paradoxically participate in the same process that makes all order, all complexity, all beauty possible. Time and consciousness, how your mind weaves the fabric of now. In the quiet sanctuary of your mind, something miraculous is happening right now. As you listen to these words, your consciousness is performing one of the most extraordinary feats in the known universe. It is creating time itself. Not the time of physics, not the time measured by atomic clocks, but the lived time of experience, the flowing stream of moments that carries your awareness from memory through the present toward anticipation. This is the time that matters most to you, the time in which your life unfolds, and it exists nowhere else in the cosmos but within the delicate neural symphony of your brain. Consider this remarkable fact. The present moment you're experiencing right now is actually a construction, a carefully crafted illusion, woven from threads of the immediate past and near future. When you hear a word spoken, your brain doesn't process it letter by letter, sound by sound. Instead, it waits, gathering acoustic information over several hundred milliseconds, then presents you with the complete word as if it had arrived in a single instant. Your now is actually a brief temporal window, typically lasting between 2 and 3 seconds, within which your consciousness integrates disparate sensory inputs into a coherent experience of the present. This neural construction of the present moment reveals something profound about the relationship between consciousness and time. Time doesn't simply flow through your awareness like water through a channel. Instead, your awareness actively creates the experience of temporal flow. Your brain is constantly making predictions about what will happen next, comparing these predictions with what actually occurs, and weaving the results into the seamless narrative of conscious experience. Think about what happens when you listen to music. A melody exists not in any single note, but in the relationship between notes across time. Your brain must remember the notes that have just played, while anticipating the notes to come, holding them all together in consciousness to create the experience of melody. Without this temporal integration, music would collapse into a series of disconnected sounds. The same process that allows you to experience melody also creates your sense of living in time, rather than simply existing in a series of disconnected moments. Memory plays a crucial role in constructing your experience of time's flow. But memory is not like a video recording that faithfully preserves the past. Instead,
It's more like a creative storyteller, reconstructing past events each time you remember them, influenced by your current emotional state, your subsequent experiences, and your present understanding of the world. This means that your sense of personal history, the foundation upon which your experience of time is built, is constantly being rewritten by the very act of remembering. The plasticity of memory creates fascinating distortions in your experience of time. Childhood memories often feel incredibly vivid and detailed, giving the impression that time moved more slowly when you were young. But this isn't just nostalgia. There may be real neurological reasons why time seems to accelerate as we age. Children's brains are constantly processing novel information, laying down rich, detailed memories that later create the impression of extended duration. As adults, much of our experience becomes routine and predictable, creating fewer distinctive memories and giving time the sensation of passing more quickly. Attention also shapes your experience of temporal flow in profound ways. When you're fully absorbed in an activity you love, what psychologists call a flow state, time seems to disappear entirely. Hours can pass like minutes when you're engaged in something that perfectly matches your skills with an appropriate challenge. Conversely, when you're bored or anxious, minutes can crawl by like hours. These variations in subjective time reveal that temporal experience is intimately connected to the quality and focus of consciousness itself. Your brain contains multiple biological clocks that help regulate your experience of time. The suprachiasmatic nucleus, a tiny cluster of neurons in your hypothalamus, acts as your body's master clock, synchronizing your internal rhythms with the 24-hour cycle of day and night. But there are other timekeepers scattered throughout your nervous system. Neural circuits that track intervals, detect patterns, and help you predict when events will occur. These neural clocks can be disrupted by various factors, leading to altered experiences of time. Fever can make time feel sluggish and distorted. Certain medications can speed up or slow down your subjective sense of temporal flow. Even strong emotions can dramatically alter time perception. Moments of crisis seem to unfold in slow motion, while periods of joy flash by in what feels like an instant. The relationship between consciousness and time becomes even more mysterious when we consider altered states of awareness. During deep meditation, experienced practitioners report entering states where the normal flow of time seems to cease entirely. These aren't simply periods of mental relaxation, but genuine alterations in the neural processes that normally construct temporal experience. Brain imaging studies of meditating monks show significant changes in the activity of brain regions involved in time perception and self-awareness. Dreams offer another window into the malleable nature of conscious time. In dreams, the normal rules of temporal sequence often break down completely. You might experience your childhood home as it exists in the present, have conversations with people from different periods of your life, or live through years of experience in a single night's sleep. Dream time follows the logic of association and emotion rather than the linear progression of waking consciousness. Even more intriguingly, some people with certain types of brain damage lose their ability to experience temporal flow altogether. They exist in a kind of eternal present, unable to connect their current experience with memories of the past or anticipation of the future. These cases, though tragic,
reveal that our normal experience of time's passage depends on specific neural circuits that can be disrupted or damaged. The fact that consciousness constructs temporal experience raises profound questions about the nature of time itself. If time, as we experience it, is largely a creation of neural processing, what does this tell us about time's fundamental reality? Are we discovering that subjective time is an illusion? Or are we learning that consciousness reveals something about time that pure physics cannot capture? Some neuroscientists and philosophers argue that consciousness doesn't just experience time, it actually creates time. At least the kind of time that has meaning for living beings. From this perspective, the universe without consciousness would be timeless, a static, four-dimensional block containing all events but no flow, no passage, no narrative structure. Consciousness, in this view, is what breathes temporal life into the mathematical abstractions of physics.
This idea suggests that your experience of time right now is not just a passive reception of some external temporal flow, but an active creation, a unique contribution that consciousness makes to the universe. When you remember the past, anticipate the future, or experience the flowing present, you are not just observing time, you are participating in its creation. As you prepare to let consciousness fade into sleep, notice how your experience of time begins to dissolve. The sharp boundaries between past, present, and future become soft and permeable. Thoughts drift without logical sequence. The careful temporal constructions of waking awareness give way to the fluid time of dreams, where all moments exist simultaneously in the timeless theater of the sleeping mind. In this surrender of conscious time-making, you return temporarily to something closer to the timeless reality that may underlie all temporal experience. Time in quantum mechanics, where past and future dance in ghostly superposition. In the deepest reaches of reality, where atoms dissolve into probability clouds and particles exist in multiple states simultaneously, time itself begins to behave in ways that challenge everything we thought we knew about past, present, and future. Welcome to the quantum realm, a strange and beautiful domain where the familiar flow of time gives way to something far more mysterious and profound. Here, in the space between spaces, time doesn't simply flow from past to future, but dances in quantum superposition, existing in multiple temporal states at once, until the gentle act of observation causes it to choose a single path through the maze of possibility.
Imagine, if you will, a particle so small that it exists at the very edge of reality itself, an electron perhaps, or a photon of light. In our everyday world, we expect objects to have definite properties. They are here or there, moving or still, spinning clockwise or counterclockwise. But in the quantum realm, particles refuse to conform to such binary expectations. Instead, they exist in what physicists call superposition, a ghostly state where they embody all possible conditions simultaneously until something forces them to make a choice. This quantum superposition extends even to time itself. A quantum particle doesn't simply exist at a particular moment. It can exist across multiple moments simultaneously, experiencing what we might call temporal superposition. The particle's past, present, and possible futures blend together into a probability cloud that stretches across time itself. Only when we attempt to measure or observe the particle does this temporal uncertainty collapse into a single, definite timeline. Consider the famous double-slit experiment, one of the most beautiful and puzzling demonstrations in all of physics. When we send individual particles, photons or electrons, toward a barrier with two slits, something extraordinary happens. If we don't try to determine which slit each particle passes through, they behave as if they travel through both slits simultaneously, creating an interference pattern on a detector screen that can only be explained if each particle somehow interfered with itself. But here's where time becomes even more mysterious. Recent variations of this experiment suggest that the decision about which path the particle took can be influenced by measurements made after the particle has already reached the detector. In these delayed choice experiments, the particle seems to retroactively determine its own history based on what we choose to measure in the future. The future, in some sense, reaches back to influence the past.
This temporal strangeness in quantum mechanics
Has led some physicists to propose that time itself might be fundamentally different from what we experience in our everyday lives. In the quantum world, the sharp distinction between past and future, the arrow of time we explored earlier, becomes blurred and uncertain. Events don't necessarily unfold in a single linear sequence, but exist in a web of quantum correlations that can extend both forward and backward through time. The mathematics of quantum mechanics treats time differently than the three dimensions of space. While particles can exist in superposition across different spatial locations, creating probability clouds that extend through space, time, in quantum equations, is typically treated as a fixed parameter that flows uniformly forward. This asymmetry has puzzled physicists for decades. Why should space and time be treated so differently in quantum theory, when Einstein's relativity showed us they are intimately connected? Some theoretical physicists have proposed solutions that make time as quantum mechanical as space. In these theories, time itself can exist in superposition, branching and splitting like the paths in a quantum maze. Every moment contains within it multiple possible next moments, and reality consists of all these temporal branches existing simultaneously. From this perspective, the flow of time we experience is like following one particular path through an infinite garden of forking temporal possibilities. This idea connects beautifully with the many worlds interpretation of quantum mechanics, which suggests that every quantum measurement causes reality to split into multiple parallel branches. Each possible outcome of every quantum event occurs in its own separate timeline. From this viewpoint, you are not just experiencing one flow of time, but are simultaneously experiencing countless different timelines, each slightly different from the others. Your consciousness follows one particular branch, while countless other versions of you experience different temporal paths. The quantum entanglement phenomenon adds another layer of temporal mystery. When two particles become entangled, they maintain an instantaneous connection regardless of the distance separating them. Measuring one particle immediately affects the state of its entangled partner, even if they are light years apart. This seems to violate the cosmic speed limit we discussed earlier. Information appears to travel faster than light between entangled particles, but the quantum resolution to this puzzle is even stranger than the problem itself. The entangled particles don't actually send information to each other. Instead, they share a single quantum state that exists outside of normal space-time. Their connection transcends not just space but time itself. When we measure an entangled particle, we're not sending a signal to its partner. We're revealing a correlation that was always there in the timeless quantum realm that underlies our temporal reality. This suggests that the quantum world exists in a kind of eternal present, where all possibilities coexist in a timeless superposition. The flow of time we experience emerges only when quantum superpositions collapse into definite states, creating the sequential moments that form our timeline. In this view, classical time is like the foam on the surface of an ocean, a visible manifestation of deeper, more fundamental processes occurring in the quantum depths below.
Recent experiments in quantum physics have pushed these ideas to even more extraordinary limits. Scientists have created quantum systems where the very order of events can exist in superposition. In these setups, it's not just that event A and event B happen simultaneously. It's that the sequence A then B and B then A exist in quantum superposition until a measurement collapses the temporal order into one definite sequence. These discoveries suggest that causality itself, the relationship between cause and effect that seems so fundamental to our experience of time, might be more flexible in the quantum realm than we ever imagined. If the order of events can exist in superposition, then perhaps cause and effect are not fundamental features of reality, but emergent properties that arise when quantum superpositions collapse into classical timelines. The implications extend beyond abstract physics into the very nature of existence itself. If time at the quantum level is fundamentally different from the time we experience, then perhaps our entire sense of temporal flow is a kind of collective hallucination, a story that consciousness tells itself to make sense of the timeless quantum reality from which it emerges. Yet, for all its strangeness, quantum time might offer a kind of comfort. If all moments exist simultaneously in quantum superposition, then perhaps nothing is ever truly lost. Every experience, every relationship, every moment of beauty or love continues to exist in the timeless quantum foundation of reality. The past doesn't fade away, but remains eternally present in the quantum realm, accessible not through memory, but through the fundamental quantum connections that link all moments together. As you drift towards sleep tonight, let your mind rest in this quantum mystery. Feel yourself existing, not just in this present moment, but spread across all possible moments, in a gentle superposition of experience. In the space between waking and sleeping, between conscious thought and dream, you touch something of the quantum realm where time dissolves into pure possibility, where past and future dance together in the eternal now of quantum superposition.